Assalamu alaikum warahmatullahi wabarakatuh. We are continuing chapter number 6, heat transfer. Now let's see what is thermal expansion in liquids. As we know that liquids do not have a definite shape but they have a definite volume. This is because of their molecular arrangement. The molecules are not very closely packed. They are less closely packed than solids. So they have intermolecular spaces between them. Due to this, liquids do not have a definite shape but they have a definite volume. Liquids show only cubical or volume expansion. This I already told you that the molecules are less closely packed and have relatively less force of attraction than solids, so they can flow. Thus liquids expand more than solids on heating. So when we heat a liquid, what happens? The container also expands with the expansion of liquid. Due to this, the observed expansion of the liquid is less than its actual expansion. So when we heat a liquid, what happens? The vessel or the container in which the liquid is kept also expands. And due to this expansion, what happens? The observed expansion of the liquid is less than its actual expansion. So the observed expansion of the liquid is called apparent expansion and the actual expansion of the liquid is called real expansion. Now let's see how does the thermal expansion of a liquid occur on the basis of molecular motion. So we know that molecules are in a state of motion, and in a liquid the molecules are free to move within the boundary of the liquid as they have intermolecular spaces in between them and force of attraction is less between the molecules in comparison to the solids. So they are free to move within the boundary of the liquid. So when this liquid is heated, the molecules start moving faster. Their kinetic energy increases. So molecular space also increases. Hence the liquid expands. Let's go through some practical applications of thermal expansion of liquids. So bottles and saucepans are not filled up to the brim. Some space is left behind to avoid overflowing on heating. As we know, liquid expands on heating. So bottles and saucepans are not filled up completely. Otherwise, the liquid will overflow. On heating, it will expand and it will overflow. While filling the medicine bottles, an appropriate space is left in them. This is done to allow the liquid medicines to expand when they are sent to hot countries or regions. So when the medicines are sent to hot countries or hot regions, the bottles are not filled completely. Some space is left in them to avoid overflow of the medicines, because we know that liquid medicines will expand on heating. A mercury thermometer also works on the principle of thermal expansion of liquids. As we know, there is mercury inside the thermometer. So when the bulb of the thermometer is kept in contact with the hot object, the level of the mercury rises in the capillary tube and it shows that mercury expands on heating. And when the bulb of the thermometer is kept in contact with a cold object, the level of the mercury falls in the capillary tube and it shows that mercury contracts on cooling. And for each degree Celsius rise or fall in temperature, the mercury expands or contracts by the same volume. Volume is the same whether it expands or it contracts for each degree Celsius rise or fall in the temperature. Now thermal expansion in gases. We all know that molecules of gases are very loosely packed. They are very far apart from each other and the force of attraction is negligible between the molecules. So gas expands much more than liquids and solids on heating. As we know that the molecules in gases are very loosely packed and there are large intermolecular spaces and the force of attraction is least. So the gases do not have a definite shape and a definite volume, and they can occupy the whole of the space which is available to them, and they can flow easily, and gases undergo only cubical or volume expansion. Now we all know that the molecules of a gas are free to move anywhere in the space available to them, as they have least intermolecular force of attraction and intermolecular space is very large. So when the gas is heated, its molecules start moving more vigorously, due to which their kinetic energy increases. Thus the intermolecular space increases and the gas expands. Now let's see what is evaporation and boiling. Evaporation is the process during which a liquid changes into its gaseous state at any temperature below its boiling point. Examples are drying of wet mop floor, wet hair, and now this process of evaporation produces a cooling effect. It gives a cooling effect. When we place a drop of ether in a palm, after a few seconds the ether disappears and our palm feels cold. It is because of evaporation. So evaporation is the process during which liquid changes into its gaseous state at any temperature below its boiling point, and it gives the cooling effect. Now what is boiling? It is the process during which the liquid changes into its gaseous state at a fixed temperature on heating, and this fixed temperature is called the boiling point. Like change of water at 100 degrees Celsius to steam at 100 degrees Celsius on heating is the example of boiling. And this fixed temperature at which a liquid changes into its gaseous state is called the boiling point. Now the differences between boiling and evaporation. What is evaporation? It is a slow process and it cannot be seen, and boiling is a fast process and can be seen. We know that evaporation takes place at all temperatures and boiling takes place only at a fixed temperature, which is called the boiling point of the liquid. It is a surface phenomenon, that is, it occurs only from the surface of the liquid, and boiling is a bulk phenomenon, that is, it occurs throughout the mass of the liquid. No bubbles are formed in evaporation. In boiling, bubbles are formed. In evaporation, some molecules near the surface of the liquid, they acquire sufficient kinetic energy by absorbing heat from the surroundings. As a result, they are able to overcome the force of attraction of other molecules, so they can leave the surface easily and they escape out.